This recording, we are going to discuss number 13 in the Math 1 to 2, Statistics 1, Unit 6, Assignment 6. Let's go back to number 13. It says, if X approximates a normal distribution of a mean of 45 and a variance of 12 squared, find the probability that X is less than 54. That's part A. Part B, the probability that X is less than 39.96. And part C, the probability that X is greater than 43.56 and less than 47.4. So that means the probability that X is between 43.56 and 47.4. So let's focus on part A. To answer such a question, we can refer to Unit 6. By now we are familiar with Unit 6. And let's go down to page. These pages are used to learn how to use the standard number table to obtain probability values. And take a look at example 6.3. So 6.3 is very similar to 30. If, for example, you want to find the probability that X is less than 15. So what you do, you sketch a normal curve. On the horizontal axis, you put the population mean, which is 12 in that case, because here it is said that X approximates a normal distribution with a mean of 12 and a variance of 2 squared. So you draw a normal curve and you point out that the population mean is 12, it comes right in the middle. Now 15 is more than 12, so you draw another vertical line on the right side of 12 because the horizontal axis is a number line. So 15 is more than 12, so you draw an indication of your 15 more or less will be. And you look at the arrow is pointing towards the left, so you shade it towards the left. So when you look at this, you are trying to find a big chunk. So your answer must be more than 0.5. Now your standard normal curve, you can draw another curve, or below 12, you can put 0. All right? Right beneath 12, you can put population mean is equal to 0. And then you standardize. We all know the standardized formula. Z is equal to X minus mu over sigma. Sigma is the standard deviation. Let's go to the page for this formula. Here is the standardization formula. It says to obtain value, look, to obtain the probability values are obtained from a standard normal table after standardization has taken place using the formula Z is equal to X minus mu over sigma. So this is a process where X variables are standardized into Z values. Okay, so we'll be using this formula extensively in this chapter. So here X is 15. So we have 15 minus 12. 15 minus 12 is 3. 3 divided by 2 is 1.5. So 15 has been standardized to 1.5. So we want to find the probability that X is less than 15. That's what we're trying to find. And that would be equivalent to the probability that Z is less than 1.5. So now we can go to the standardized table and look for Z less than 1.5. Because we are trying to find a shaded region towards the left, it's not a tail, it's a big chunk, but nonetheless it's towards the left. We can simplify the notation to phi of. So that's just a simplified notation. We are trying to find phi of 1.5. So all we simply do is to go to the standard normal table and look for Z 1.5, and whatever probability value we get for 1.5, that is phi of 1.5. So we look for z, we go down and look for 1.50, and the answer is 0.9332, and that's phi of a positive value, which is here, coincides with the table, a big chunk. Okay, so therefore that's our final answer for part A, 0.9332. Right here. So that should help us with part B, because 54 is more than 45, just like how 15 is more than 12. Okay, now part B now, it says x, the probability, we're trying to find the probability that x is less than 39.96. Now 39.96 is less than 45. Okay, so we are shading towards the left a value which is less than 45. So let's try to get an example similar to this. So by the way, that's a phi of it. That's a phi of 39.96, because the arrow is pointing towards the left. So we have found a situation similar to part B, where our x is less than 39.96. So when we standardize, x is 43.56. So when we say x minus mu, 43.56 minus 45, we are going to get a negative value for z, because remember, the standard deviation is always a positive number. Okay, so therefore now, we're going to get a negative value for z. So we're going to find ourselves in a left tail. Now, if you're looking for a left tail, you must do a 1 minus, whatever tail it is. Right tail, left tail, you must do a 1 minus. So similar situation for a left tail, here it is, negative 1.6. So you have to find phi of, for example, here, phi of 1.6 and subtract it from 1. A phi of 1.6, right, is a big chunk. Subtract it from 1, it will give us a tail, left tail and right tail. The values are equal for a particular value of z, because the curve is symmetric. So we must find a phi of the z value and subtract it from 1, and that should give us a probability value less than 0.5 or less than 0.5. So our solution for part B should be less than 0.5, because this is a left tail. What about the probability that x is between 43.56 and 47.4? 43.56 is less than 45, and 47 is more than 45. So we are in a similar situation like this, because we're trying to find an in between. So let's look at an in between for similar to part C. So this is going to give us a negative z, 43 is less than 45, and this is going to give us a positive z, 47 is more than 45. So we're in a similar situation like this one then. We're trying to find an in between on the left side of 0 and on the right side of 0. Okay, so therefore now what we're going to do is to find phi of both of them and subtract them from each other. Phi of the positive, we can get it straight from the table, is a big chunk, was less than 1.56, 1.65, for example. We're going to get a value more than 0.5. And phi of the negative is a tail, so we must do a 1 minus. Find the phi of the positive, subtract from 1 to give us the tail. We're going to get a value less than 0.5, and then subtract each other to find our final answer. So for part C, is a very similar looking to this example here. So hopefully this helps us to answer number 13.